How then do you also identify the group and period of an element on a periodic table? How do you then also identify the group and period of an element on the periodic table? So let's take one element here, hydrogen. Hydrogen has a configuration of 1s1. Is that okay? So over here, hydrogen has only one electron, so we won't talk much about it. The principal quantum number here, or the shell, indicates the period of hydrogen. And the principal quantum number here is 1. So it indicates that hydrogen is in period 1. Is that okay? So now let's look at the periods. The first one here is called period 1. So this is P1. This becomes P2, that is period 2. This is P3. This is P4. Is that okay? So hydrogen, the first number, that is the principal quantum number, represents the period of that element. So hydrogen is in period 1. And then since it has only one electron, we assume that this one electron is the only electron in the outermost shell of hydrogen. So it is in group 1. Is that okay? So this representing the period, and this one talking about the group. So hydrogen is in group 1, and then also in period 1. Let's take another element. Let's take carbon. Carbon is atomic number 6. Carbon is atomic number 6. Let's try the configuration. Carbon is 1s2, 2s2, 2p2. Is that okay? 1s2, 2s2, 2p2. Now, the outermost orbitals, or the outermost energy level for carbon, is the 2p orbital. So in the 2p orbital, we have the 2s and then the 2p. Is that okay? Now, how many electrons are found in the second shell? That is the last shell of the carbon. How many electrons are located over there? We have 2 in the s orbital and then 2 in the p orbital, giving us a total of 4 electrons. Is that okay? So these 4 electrons here indicates the group of carbon. The number of electrons, the total number of electrons in the last orbital represents the group of that element. So for carbon, it has 2 electrons in the 2s orbital and then the 2p orbital. That is the last energy level, the 2. So just add the total number of electrons, it will tell you the group of that element. So that is 4. So we say that carbon is in group 4. And indeed, carbon is in group 4. And also, the last shell, or the last principal quantum number in the configuration here is the 2. So the 2 over here means that carbon is in period 2. Carbon is in period 2. So the 2, which indicates the last energy level, where we can locate the electrons, for the last electrons, for the valence electrons, is in the second shell. So we say that carbon is in period 2. Is that okay? Let's take another example as well. Let's also consider sodium. Let's take sodium. Na. Sodium is atomic number 11. Sodium has a configuration of 1s2, 2s2, 2p6, and then 3s1. 1s2, 2s2, 2p6, and then 3s1. That is the configuration of sodium. Now, what is the last energy level of sodium? That is in the third shell. That is the third orbital. So that is the 3s orbital. That is the last orbital of sodium. So the last orbital here indicates that the sodium is in period 3. So now let's check sodium, Na. It is in period 3. Is that okay? Now how do we identify the group? The last electron found in the last orbital. The last electrons located in the last orbital. So the last orbital is the 3s orbital only. So we have only one electron. So the one electron here indicates that sodium is in group 1. So let's look at sodium Na. It falls under group 1. Is that okay? Let's look at another example. Let's take magnesium, Mg. Magnesium is atomic number 12. It has the configuration 1s2, 2s2, 2p6, and then 3s2. This is the configuration for magnesium. What is the last energy level of magnesium? That is the 3, which contains the s orbital. So the last orbital here is the 3s orbital. What does the 3 represent here? The 3 represents the period of magnesium. So we say magnesium is in period 3. And let's check whether it is true. Yes, indeed, Mg falls under the 3rd horizontal arrangement. That is the 3rd period. Is that okay? Also, what is the group of magnesium? The number of electrons located in the last orbital or the last energy levels. The last energy level is magnesium. In magnesium is the 3rd shell, and the orbital present is the s orbital. It has only 2 electrons. So the 2 electrons over here indicates that magnesium is in group 2. And then Mg indeed is located in group 2 as well. Is that okay? Let's take another example. Let's consider chlorine, Cl. Chlorine is atomic number 17 on the periodic table. It has a configuration 1s2, 2s2, 2p6, 3s2, 3p5. So this is a configuration for chlorine. Is that okay? This is a configuration for chlorine. Now, what is the last energy level? The principal quantum number here, the last one is the 3rd one. So in the 3rd energy level, we have the 3s2 and then the 3p5. Is that okay? So the 3rd energy level here indicates that chlorine is in period 3. So indeed, when you check the periodic table on the board, you can use the modernized one as well. Period 3, we have chlorine over there in period 3. Is that okay? Now, how do we identify the group of chlorine? So indeed, to identify a group as well, we add the total number of electrons located in the last energy level. So we have 2 in the s orbital and then 5 in the p orbital. 2 plus 5 is going to give us what? 7. So chlorine is in group 7. Is that okay? Chlorine is in group 7. It is a group 7 element. Is that okay? So that is how to also identify the group and period of elements on a periodic table as well. Is that okay? Now also let's talk about blocks of elements. Blocks of elements. Blocks of elements. So we have the S block elements, we have the P block elements, the D block elements, and then the F block elements. So with the blocks of elements, we have the S block elements, the P block elements, we have the D blocks elements, we also have the F block elements as well. What is the meaning of all these blocks of elements? The block of elements simply means that the element has its last orbital, the element has its last electron in that orbital. So if an element has its valence electrons located in the s orbital, it is an s block element. If it has its valence electron located on the s orbital, it is an s block element. If it has its valence electron located in a p orbital, it is a p block element. If we have its valence electron in the d orbital, it is a d block element. if it has a valence electron in the f orbital, it is an f block element. It is an f block element. So I have a picture indicating the blocks of elements for various elements on the periodic table. So we can see that with the S block elements, we have hydrogen, lithium, sodium, potassium, rubidium, cesium, and then francium. In addition to that, we have helium, beryllium, magnesium, calcium, strontium, barium, and then radon, forming the S block elements. It simply means that all these elements have their valence electron or their last electron in the S orbital. Is that okay? They all have their last electron in the S orbital. Let's prove that. Let's take some of them. So I have hydrogen, helium, beryllium. So hydrogen is an S block element. Why? When I write the configuration for hydrogen, 1s1, hydrogen has only one electron. That electron is located in the S orbital. So hydrogen is an S block element. Is that okay? Let's take helium. Helium is atomic number 2. Its configuration is 1s2. Helium has 2 electrons, and that 2 electrons is located in the S orbital. So since it has its electrons in the S orbital, that is the only electron present in the S orbital, it is an S block element. Is that okay? Let's take sodium. Na. Atomic number 11. It has a configuration 1s2, 2s2, 2p6, and then 3s1. Is that okay? Now, sodium has its last electron located on the S orbital. So sodium is an S block element. Is that okay? Let's take boron. Boron is atomic number 5. Its configuration is 1s2, 2s2, 2p1. The last electron in the last shell of boron is present on the p orbital. So we say that boron is a p block element. So for the blocks of elements, when the valence electron or the last electron is present in that orbital, if it is present in the s orbital, it is an s block element. If it is present in the p orbital, it is a p block element. If it is also present in the d orbital, it is a d block element. If it is present in the f orbital, it is an f block element as well. Thank you.